But despite their power, most developers, and probably most of us here in the room, have actually never tried them in practice. Why? Well, maybe because the experience can look a little bit like this. So today I'm going to show you exactly what makes liquid types frustrating to use in practice by presenting our study on the usability barriers for liquid types. I'm Catarina Gamboa, and this is a joint work by CMU and the University of Lisbon. So type systems are useful in verification, but sometimes we cannot encode some domain-specific information. But with logically qualified types, or liquid types, we can add predicates to our language, to the types of our language, by saying, for example, that an array needs to have a length greater than 0. Then we can apply them to our functions and verify them at compile time to ensure that our code is following these properties. And liquid types, basically on the background, create these verification conditions that we can send to an SMT solver that will check their satisfiability so that we can see if the verification passes or not. And liquid types have been implemented in several languages. And they have also been used in different use cases, from protocol violations to try to find the security in cryptographic protocols, MVC applications, and database queries. But despite all of these different applications and implementations, the fact is that most developers still are not using them. So our main research question for this paper was, what are the current usability barriers that developers face in adopting liquid types? And when we started thinking about this, we started to think, how can we answer this question? And how do we know what are developers' doubts and decisions and their intermediate steps and difficulties in learning and using liquid types? Well, and the answer is just one. We need to ask developers. So we did interviews and observed developers using liquid types, specifically using LiquidHaskell, which is the most mature implementation of liquid types at the moment. And so we interviewed participants with different levels of experience with liquid types, and also both from academia and in industry. At the end, we got 12 new users that were participants that did not know about liquid types, but already knew about the target language, so Haskell, and several experienced users that had already used LiquidHaskell in one of their projects. And for all of them, we did different qualitative research methods, such as interviews, observations, retrospectives, and using think-aloud protocols. So how does our study look like? Our study design starts by having people sign up and tell us if they already used LiquidHaskell or not in the past. If they didn't, but if they already know Haskell, they are our new users. And so we introduced LiquidHaskell to them with a short tutorial of 30 minutes. Then we asked them to do a final exercise where they had to mix different parts of using liquid types, from writing them to reading them, also fixing them in different parts, and implementing code that respected the liquid type. At the end, we did a small interview to understand what were the challenges that developers faced and also their overall experience. For experienced users, so participants that had already had projects using LiquidHaskell, we started by doing an interview to try to understand what were the pain points, but then we also thought it was important to focus on a project where they used LiquidHaskell to anchor their experiences in the code and also make them remember other different parts that they did not remember for the interview. Then, if the experienced participant had a project at the moment that used LiquidHaskell, we actually asked them to work in that project for around 30 minutes while we observed. And they would work like our master, and we were the apprentices trying to understand what were their thought processes and how they were going to go about their work. If they were not using LiquidHaskell at the moment, so the project probably already finished a while ago, we asked them to do a retrospective, and so to try to understand again what they did in their project and show us the most interesting parts. So overall, we did a study with those numbers of participants that I mentioned before, and we came up with 9 adoption barriers overall. All of them were shared between our participants, and interestingly, all the problems mentioned by our new users were also mentioned by our experienced users, but in different levels of complexity. But there were some other specific parts that were only mentioned by our experienced users, given that the code that they were using was more complex and they had more time to experiment with it. We combined these all barriers in 3 main parts. So the first one is verification challenges, where we have then clear divides between Haskell and LiquidHaskell, confusing verification features and unfamiliarity with proof engineering. Then we have developer experience challenges that are a little bit more related to unhelpful error messages, limited IDE support, complex installation and setup, and some insufficient learning and reference resources. And finally, we have some scalability challenges that include some limitations of automation and manual proof flexibility, and also scalability and solver limitations. And I'll now walk through some of the examples of each one of these categories. So starting with the verification challenges, let's start with a simple example. You don't need to understand all the code, but this is basically a function that has these front and back lists, and then has to create a new list where everything follows through. And we gave this exercise to our participants. Actually, we just gave them the implementation without the specification, and they were very puzzled with this implementation. From the start, they were like, this is interesting. We have only one base case, only for front. So where's the base case for back? Doesn't really make sense. So it actually only makes sense if we also look at the specification, the liquid type, where we say that B is also a list, but that has the size of exactly the size of F, the first one, plus 1. And so if it's always bigger than the first list, then we just need one base case. And this was very interesting, because they were expecting this part to be in the implementation, but now it is in the liquid type. So it actually shows that there is this symbiosis between the liquid type and the implementation, where some changes in the code might be required or might be possible because we have the accessible to both those parts. Actually, one of our participants also really felt like they had to change the Haskell code to fit into the verification. They mentioned that they found themselves writing code in certain ways, or found the code being written in certain ways to convince the proof assistants that were necessarily not the most intuitive for them. Also, our participants think that liquid types can be this middle turn between a very good type system, but they don't really have to, or a full type system with dependent types, for example, where they don't need to have a doctorate degree to understand what's going on. But still, you need to have an intuition of what's going inside the liquid types. And so you still need to identify what are the pre and post conditions, what are the requirements that you have for your programs, and what predicates you need to write to ensure that the properties hold. One of our participants, for that example that I showed you before, the rotate example, they mentioned that I think if I had to come up with a type of rotate by myself, trying to figure out this invariant should be quite difficult. As a small fun fact, we did try that in our pilots, and just that exercise went more than 30 minutes, so we decided to drop it and change it for something slightly different. There are also some confusing verification features that I will not go a lot in depth into, but that are related to lifting functions as measures or the mechanics of how the SMT works. As for developer experience challenges, I'm going to show you another piece of code where we have this new type, qn, that actually just uses this qsize function or measure, but does not apply it to a certain element. And so this gives an error. But actually, it gives 3 errors, all in different places from the place where the actual error was made. And so there is this error indirection between where the error appears and the actual location where it should be fixed. Additionally, if you touch in one of these and try to see what are their messages, this is more or less what it shows. Okay, and again, you don't need to read all of this, but if we focus here on the part that it's larger, you can see that we have these variables VV0 and AA2CB that appear nowhere in our code. So they are very helpful for our verification in our internal representation, but if we show this to user, we actually have this code mismatch that we cannot relate their message to the code. One of our experienced participants also mentioned this problem in a different scale. They mentioned, well, tell me what the type error is. No, instead you get a message like 5 is not less than 4. I mean, I know that's true, but what does that mean? Also, even this problem could be a little bit improved by some IDE support. For example, by having some syntax highlighting. But actually, in most cases, we do not have that. And the fact of having these liquid types as comments, that's sort of an emotional thing where you kind of feel that the things that you're writing are fake. So usually, our comments are just to comment things. They are optional. They are not used for verification. So even the simple thing of using comments as the liquid types can endanger the experience of the users. Also, it does not help that some of the compilation and setup can be a little bit difficult. One of our new users mentioned that they tried to use and install LiquidHaskell before coming to our study, and they failed miserably. So that's one reason why they might not be too inclined to use liquid types in the future. When people experience these problems, usually they use the tutorial that's available online, the Slack groups, the GitHub issues, but the community is still small. And the tutorial is very helpful if you're starting out, but when you have more problems with advanced features, it might be a little bit more difficult. As for the scalability challenges, we have this program that we sent to the SMT solver, basically. And we use the SMT solver as more or less a black box, which can be very helpful because you're constantly being supported by it. But also, you need to get to a point where you can automate the proof. So you kind of need to understand what is that point that you need to get to. And that is the challenge. So this brings some of the limitations of automation and manual proof flexibility. Also, when the program and the proof complexity starts to increase, there is also an increase of the compilation time. One of our participants mentioned that at the end, if they ran the whole proof until the end, it would take 5 hours or so, or maybe longer for all the thing to verify. Also, we need to be aware of some of the internal solver limitations. We treat them as black boxes, but sometimes you need to understand a little bit more of what's going inside. So for example, not everything can be converted to the language of the SMT solver, and some things can fail, and you still need to understand why. So overall, we have these 3 categories of challenges that we found, and you might be wondering, are these barriers specific to LiquidHaskell, since we kind of did this study just on LiquidHaskell? So let's go back to some of them. Let's start with this unclear divide between Haskell and LiquidHaskell. Well, actually, most of the implementations that I showed you at the beginning focus on the target language and add the liquid types on top of them. So other liquid types implementations like Flux or Liquid Java might also suffer from some of these problems. Additionally, one of our participants mentioned that for the confusing verification features and unfamiliarity with proof engineering, that they only see their colleagues actually using liquid types as more of a lightweight verification tool and not a full verification, which demands a deeper understanding and finer grained control over the proofs. So maybe viewing them a little bit more as a lightweight verification technique can be helpful. As for the developer experience challenges, well, I think there was a talk about Rust in here yesterday that also explored some of these problems. And also the IDE support, even the example that I showed to you about the comments, is shared with other languages that also use the verification in comments. Additionally, for the complex installation and setup, some of our participants mentioned that developers will probably go on their first day on the job and test it. If they can use it in the first 5 minutes, they'll probably use it later on. If not, they'll probably give up and not touch it for at least a couple months. As for the scalability challenges, specifically related to the SMT solver, other tools that will also use SMT solver backends can also be endangered by these problems. So overall, these challenges are not just specific to LiquidHaskell, maybe not even just to liquid types, but listening to our developers, we can better understand what are their struggles. And so together as a community, we can improve the design and implementation of our languages, trying to reduce the usability barriers. If you want to know more, we have our paper, and if you want to participate in our future studies, you can leave your email for future studies. Thank you very much.
All right, thank you, Catarina. And now we'll open up for questions.
Great talk, thank you so much. So you have focused on a specific verification paradigm, refinement types, and even more so specific tools. So now imagine I'm going to build the next awesome verifier that everyone should use. Which things should I look for, and which mistake I should absolutely not make when designing it?
Well, there are many things that we can work on, and this was just like an overview of different challenges that you have to do. I would say that trying to bring the users into the development process from a start could be a good idea. To try to understand what do you want to verify, how do you want to verify it, and not just build our tools and then ask afterwards if they enjoyed it. So I think that from one perspective, it could be helpful to bring developers or the potential users a little bit more to the beginning of the process, into the design perspective, to understand what could be some of the challenges that they want to fix and how we can overcome those. But then all of the challenges that we mentioned here could be relevant to tackle in different parts of the process.
Well, yeah, I'm more interested about how to bootstrap this exact process, because building verifier is a challenging task, and well, it would be good to know how to get some early feedback, well, cheaply. But this is something that we can discuss offline.
Thank you.
Okay, and please be sure to state your name and your affiliation.
Hi, Leonard from University of Montreal. Really great talk. I had a question. During the study, did you notice like features that users expected should work but wasn't supported by the system?
Yeah. So some of our participants, even for the new users that were not familiar with liquid types, they actually had already used some tier improvers in the past, so they're already familiar with some things. And so they were expecting to have some more manual control over the different predicates that you can use, because they were expecting more of the interactive tier improver approach. And so there were some things that they were expecting to have from that landscape brought into the liquid types, and actually they didn't find them. So there were a few things. I can then show you some of them, but there were some of the things that they were expecting because they were already familiar with other applications that were kind of in the similar landscape.
Okay, thank you.
Hi, thank you for the great talk. I'm Hyunri from Seoul National University. So about the problem in IDE support for liquid type language, I wonder the reason why there's a problem in this language is just because of the fundamental lack of enough developer, or is there a fundamental difficulties on that?
So if I understood correctly, so liquid types actually can be very helpful and useful, and even our experienced users that are not using them at the moment would actually use them again if they needed to verify other things or if they were using Haskell. But there are some challenges still that appear, specifically when your program starts to grow and you still need to understand everything that's going on. For example, trying to find what are some of the parts of the code that are sent to the SMT solver and what are not being able to verify, or what's the condition that's missing for you to verify everything, can be a challenge. And so this is overall like a landscape of different challenges that we have. Are those really dependent with the implementation? Some of them might be a little bit, but a lot of them are more generic, and we can just use more research into understanding them better.
Okay, we have maybe time for one short question.
I'm Mellon from Jane Street. You mentioned that some of your users found it weird to write liquid types in comments, and I'm wondering whether there's syntax highlighting for those comments, or if there's maybe some other more native syntax construct you could use to alleviate some of that difficulty.
Yeah. So in this case, our new users were using our tutorial mostly to do everything, and so we did not have any syntax highlighting. Also, in most of the editors that are available, they do not have syntax highlighting at the moment. And we can think of that it's very simple. It's something that you can actually do, but people don't. And so trying to understand a little bit of the things that developers might want to have can be very interesting to overcome these simple difficulties that we don't realize that are problems until actually someone tells us that it is a problem. So yeah, I think that's it.
We can thank our speaker again.
Thank you.